at example 2. Everybody's looking at example 2, and we are going to find the open intervals where H is increasing. So what do you think the problem is? Where do you think that curve is increasing? Who has a thought? Negative 2. Okay, let's talk about that. -2-3, you say? Okay. Okay, let's look at that for a second. So -2. And then 3 is right down here. So would you say that curve is increasing on that entire part?
That'd be -2 to 0.
There we go, -2 to 0. Remember, when you write an interval like this, we're talking about x values. We're talking about going left to right, so we're looking at the x's. So would you agree -2 to 0? Is there any other part of the curve that is increasing?
2 to 7.
4 to 7? And that's it for increasing? Okay. How about decreasing? What are our intervals for decreasing? Remember, we're looking at x's.
-4 to -2.
Is that it?
2 to 4 and 3 to, or 0 to 2. Yeah, 0 to 2 first.
0 to 2. Okay. And then,
2 to 4. Oh wait, can you just combine the 0?
yeah. So we'll just go 0 to 4. The curve's going down on that whole part. And then that's it. Where would you say that curve is concave up? I would definitely say 2 to 7. Would you say 2 to 7, the thing is concave up? Now, it's a little bit tricky because that first part, this part right here, where it goes like this is actually called a cusp. This is linear, so there's no concavity there. All right? So it is not concave anything on that part. But this part, from -2 to 2, that part is concave. Oh wait, that wasn't the question. I'll say that part is concave down. Would everybody agree with that? So this was concave up, and this was concave down. I know, it just does that periodically. It'll be fine, it just does that.
Is concave the one with the water? Like you said,
Concave up, means like this, yes. Yes. Like a U. All right, D says, where are we both increasing and concave down? So the curve is increasing and concave down. Is there any part of the picture that meets those qualifications?
2 to 0.
-2 to 0, absolutely. Because -2 to 0 is definitely on the concave down part, but your pencil is going up as you draw it. Is there any other part like that? Okay. Decreasing and concave up. Is there a part of the picture that is decreasing and concave up?
2 to 4.
2 to 4 is decreasing and concave up. That's exactly right. Are there any other parts of it? I don't think so. Okay. Now you're going to get to do something funny. Example 3. Okay, so example 2, you had the picture and you answered these, or made these statements. Now, the statements are made for you and you're going to create a picture that satisfies those statements, right? So you and your partner take a minute, and then we'll get a couple of ideas up here on the board. See if you can design a picture that satisfies those requirements. Good? I need another set to go up. It's so great. Head up there.
Should we do Brad?
You and your.
We're doing a lot of different ones at the same time.
No, I want, yeah, I want to.
Okay, wait.
Hopefully they're similar, but, they could be a little bit different.
Wait, you want me to put, wait.
No, you're not. Wait, do I? You're not. Oh,
There. Is that like that? That's all
My
line.
pocket.
And then it goes like
It was like-
down to 5. 5 is the little space. Right? It's decreasing from 1 to 5. It's decreasing from 1 to 5, but it's so 5 has to be the lowest point. It has to be like,
You guys just squeeze in there.
and then first, like, right?
Guys, and they squeeze in behind so you can get the picture done.
Oh, yeah.
It was very on.
Why can we have more than one picture? What do we not know anything about? We don't know anything
Here,
about
this
the
is
Y.
like really confusing. I'm gonna make it
So,
look
they're both starting above the x-axis, but they could have points below the x-axis.
increasing, and then we'll it's increasing to 1. And then 5 to 7 is increasing. Oh, wait. But it's still increasing through 7, so I don't think goes down here. And it just keeps showing that
That's good, you guys.
and it's increasing.
You're fine. We're gonna check your answer though now. We're gonna see if you're right.
Okay, 6 to 7. Well, how does that work? How can it? For
It's magic.
wait, like for it's supposed to be increasing from 5 to 7, but then also it's concave down from 6 to 7. So how do you make it concave down without making 6 to 7 making 6? Okay. Okay, I think that's right.
Alright, let's take a look at this. This is draft 1. Let's see if it meets the qualifications. From -4 to 1, we are increasing. Yeah, that's right there, maximum, it looks like. And from 5 to 7, we are increasing. That looks good. Decreasing from 1 to 5. Yep, that looks good. Concave up from concave up from 3 to 6. So yeah, I guess so. Yeah, that looks all right. And concave down from -4 to 3, and from 6 to 7. Yep, that looks good. That looks good. I like this picture. This picture's all right. What's happening over here? Increasing from -4 to 1. Yep. Oops, Sam and Celeste.
Yeah, we messed up at the end.
Yeah, because from 5 to 7, we're supposed to be increasing, and you guys have a little other option. Alright, so we'll just do that for now, from 5 to 7 for increasing. Decreasing 1 to 5. Concave down from -4 to 3, that part's right. Concave up from 3 to 6. And then concave down from 6 to 7. So right here, we change from being concave up to being concave down. That's called a point of inflection. But yeah, look how similar the pictures are. Good job, guys. Very, very good. All right. There's a lot of stuff here. There's one section you need to do. So turn. Did I number those pages? Turn it. All right. Turn to the page. Better go forward a couple pages here. On the back of the business cycle. On the back of the business cycle page. So one of the pages is about the business cycle. One of the back. We have until 10:10. Oh, wait, so we can do a couple other things, but we want to do this one. All right, so once again, with your partner, take a look at these questions, 1 through 6, and see what you can figure out. Come on, use each other, help each other. So we're doing 1 through 6 on the back of the business cycle page. The point of inflection is this point right here where the curvature changes. Where it goes from being concave up to being concave down or vice versa. That's called a point of inflection.
I just want you to edit everything.
Wait, isn't this concave now? Oh, I got them mixed up. Yeah. This? So like, just make, I don't or I feel like it was like 0.5.
Yeah. But I feel like that doesn't.
Because this at some point changes over.
I don't know.
All right, what did you think about number one? Is the function increasing or decreasing at x equals -1? What did you say? Increasing.
Yeah.
And how do we know? How do you justify that answer? The slope is positive. The slope is positive. Increasing means you're going up. Think about that. That means your slope is positive. Very good. Is the rate of change of f increasing or decreasing at -1? So at -1 is the rate of change increasing or decreasing? Decreasing. How do I know? It's concave down. Remember, concavity tells you about the rate of change, how it is changing. So the answer to 2 is the rate of change is decreasing because at that point the curve is concave down. On which interval is the graph concave down? Actually, I can go with the negative infinity part. There's really no arrow on that, so I don't know what's happening there. So you might say -2, but I can live with negative infinity for sure. So either -2 or negative infinity. There's no arrow, so it's a little confusing. But I don't think it's concave all the way to 2. I think here we're concave up, aren't we? So where does that concavity change? Like right around there, it changes from being concave down to being concave up. I don't know what that point is, but I said 0.5. Approximately 0.5. So we are concave down from the beginning of the picture, whether that's negative infinity or -2, from the beginning of the picture until we get to here. And then all of a sudden we become concave up. So where's it concave up? From 0.5 to the end of the picture. So either positive infinity or, well, yeah, I don't know, 3 point whatever. But yeah, all the rest of it is concave up. The X value of the point of inflection, I already estimated to be 0.5. Describe what this point tells you about how F is changing. What did you say for that? How did you describe the curve at that point? The curve is decreasing at an increasing rate. At that point, it's changing the fastest. That is the point where the slope is the steepest. It's changing the fastest at that point. The curve, the rate of change is the highest at that point because the slope is the steepest. Points are falling faster there than they are anywhere else. At that instant, the slope is the steepest. Rate of change is the fastest. All right. Now, did you get to this last one where you had to fill in the points? Fill in the numbers? So let's make sure you understand what's going on. The rate of change, so the Y values here in my chart, these values right here, they give you some. They give you those 5 numbers. And they tell you to put them where they belong in here. So let's look at 9.75. Where do you think 9.75 is going to fall in here? Now remember, rate of change is the slope. So where do you think the slope is 9.75? And my choices are -1.5, so like in here somewhere, -1, 0, 0.5, and 2.
0.5.
What?
0.5.
For 9.75?
But it's negative, like it's positive.
It's a positive number.
Is it
Is
negative?
the slope positive at here? No, so that can't be positive. All right,
I guess
-1.5,
-1.5.
Charlie says, is 9.75, and what is your, argument there?
My argument is that like, the other only point that the slope is going up pretty much is at 2, and it's just starting to go up. So I think that the strongest and the steepest slope going upwards is at that point.
Yeah. Positive, perfect. All right, where do you think, let's see, how about 4? Where are you gonna put 4? -1 is like over here. Is the slope, look at their picture, not mine. Is the slope still positive at -1? But not as steep as the other one, so I think -1 is 4. All right, what's happening at 0, let's say? How about 1, the number +1? Charlie already told us. Isn't that here? Because that has positive slope, but it's not very steep. All right, how about -3 and -4.5? What do you think? Doesn't it have to be like this? Because if that's our point of inflection, or close to it, we don't know exactly what it is, but it's close to the point of inflection, that has to be steeper than what's happening at 0. Is that okay? There's a lot to think about. It gets really, really confusing. All right, let's back up a couple of pages. And let's go to the back of the how does the food industry set prices page. How does the food industry set prices? Go to the back. Look at graph number 4. Pick problem number 4. The y-axis is revenue, so it's dollars, in millions, and that's income, revenue, that's how much the company makes. And then the x-axis is the price of the rating formula. Okay, you understand that? So profit, not necessarily profit, but revenue, income is on the y-axis, and the price of the rating formula is on the x-axis. Does each equal increase in price change the revenue by a constant amount? Violet is shaking her head adamantly, no. Why not, Violet?
Because if you make it too expensive, then people aren't gonna buy it. And so.
Okay,
Do
okay,
you want like
the math, yeah, there's a math reason.
The rate of change is constant.
Exactly, it's a curve. If the rate of change is constant, remember rate of change is slope? If the slope is a number, what figure do you have? You don't have this, you have a line, right? So the math is, this is not linear, okay? The reason, the economic reason is, if it were linear, it would mean that every time I raise my price, I would sell more baby formula. Is that true? Maybe for a period it might be true, but then, like she said, at some point people are gonna stop buying it. A new intern suggests selling the formula for $20. Is this the best price? No, Kate, why? It's not the highest. The best price would be the maximum, right? Yes, so no, it's not. I mean, it's a decent price, but it's not the best price for sure. Second intern suggests $80. What do you think about that? Well, it's still not the best. Would it be better than 20? Yeah, you make more money, bring in more money. If the goal is to make the most money, the optimal price would be 60. At what prices will the company make no money on formula? Why? Well, obviously 0, right? If you don't, if you sell it for nothing, you won't make any money, obviously. But on the other end, if you sell it for 118, you're not gonna make any money either, because what's happened? You've outpriced it, right? I mean, nobody can afford to buy it. When or why might company use factors besides revenue to determine their prices? Can you think of any time when it might not be all about making the most money that you can?
Like what the competitors are doing.
What the competitors are doing? So if I'm a gas station, and by the way, doesn't it just hurt you that all of a sudden gas is like 50 cents a gallon and more expensive? That just makes me so angry. But anyway, so let's say I'm a gas station, and in order to make the most money, I have to sell my gas at, $3 a gallon. But the guy down the street is selling his for $2.80. I'm probably not gonna sell mine for $3 because I won't get any business, right? So yep, that's a great point. Can anybody think of another reason? Make it affordable, especially in times of crisis. So like during COVID, there were times that I know businesses weren't making as much money as they could have because they were trying to be good citizens. Yeah, good, very good. All right. Go to the back of the page that says, can we predict maximum heart rate? Can we predict maximum heart rate? All this is in 1.1. So yeah, I'm just kind of getting down to get down in 1.1. There's a lot of little exercises here. All right, let's look at number 1. The volume of a sphere, they give me a formula. What is the independent variable of that function? The independent variable are radius, and the dependent variable is volume, because the volume of the sphere depends on the radius, right? All right, so go ahead and complete the table of values. And once you get your values in there, go ahead and see if you can answer C. 1C. I'm not sure about doing that fast. Just plugging those numbers in. So first of all, are those okay? All right. Question C. Describe how increasing the radius affects the volume.
So that increases the volume and it increases the rate of change.
Whoa, say that again.
It increases the volume and it increases the rate of change.
It increases the volume at an increasing rate. First of all, is the volume increasing? I also did these decimally so that I could do a good comparison. This was like 4, this is 13. These are rounded off, probably not correctly, but you can see what's happening. Obviously, they're positive, we're going up. But look, here it goes up by roughly 100. Here it goes up by 400. And here it goes up by like 900. Can you describe the curve? If you were to graph this thing, can you describe it?
It's concave up.
All positive and concave up, right? Now, we haven't, you and I, haven't discussed cubic functions, and this is a cubic function. But do you remember from your previous work that cubic functions have that shape? Now, you might remember they have this kind of a shape, but that is only when you introduce additions and subtractions into the problem. So you have a cube like this. All right, that's going to have this shape. When all you have is the cubic term, which is how you got here. It's got a coefficient, but it's just x cubed. This is the shape you're going to have. And given this problem, where R is the radius and V is the volume, we don't even have that part of it, do we? Because you can't have a negative radius. So this is really the only part of the curve that we're considering for this problem. And notice it's increasing and concave up, which is exactly what you determined from the points. Very, very good. Nicely done. Nicely done. All right. Homework assigned today is 1.1. We're going to do 1.1 homework for today.
Point of interruption for looking out
Next time.
Please remember, under this period, all students and educators should report to the 4 areas. Please check your email for updates on 4 areas. Also, please remember that